For my project, I wanted to create a way to view similarities in text which is based off of not only the content of a text sample, but also the context of the words within it. To view this similarity, I attempted to create what I call a word map, which gives a visual representation of the connections words have with one another. This would give not only a new way for people to view the context of an article, but also a new way for computers to further analyze the similarities between text. To find the connections between words, I used the river formation dynamics algorithm, which mimics the way new rivers form in mountainous regions. To be successful, the word maps that the program created would have to have a similarity measurement that correlated with the similarity measurement I gathered from having people rate the similarity of the same text samples. The program would first find the frequency of all quadgrams, or four-letter sequences, in the text sample, and the frequency of each quadgram in a word would be normalized to find its word weight. Past studies have shown that quadgram analysis of text yields better words in the context of those samples. For example, if there's an article about different types of sciences and holds words such as zoology, biology, and psychology, these would not be considered important in a simple word frequency count. But with quadgrams, the four-letter string LOGY would be very frequent, and therefore the word weight of each of these three terms would be higher. Each word was then placed on a high-dimensional map with their word weight dictating their spot, and the river formation dynamics algorithm began to create paths in the text, which would eventually converge onto a single word at altitude 0 or sea level. However, this system could not converge onto a single solution and failed to create a word map. My second attempt to create word maps used the traveling salesman problem, where there's a salesman who wants to travel to a large number of cities exactly once and return home in the shortest possible distance. This concept allowed me to create circular word maps. After creating and testing 25 of these circular word maps, I found that the similarity metric that they created did not correlate with the human metric. In conclusion, I could not create a word map based around only quadgram analysis and the river formation dynamics algorithm to correlate with human measures of contextual similarity. In the future, more factors, such as proximity of words to each other, should be considered in creating these word maps, and hopefully they will give better results.